All right, let's take a look at this rectangular prism here. We're going to use this rectangular prism in order to come up with a method for finding the prism of any, or the volume of any prism, regardless of what shape the base is. So let's first start with a little bit of review. If we wanted to find the volume of this rectangular prism, we previously would have taken the length and multiplied it by the width and multiplied it by the height. In this case, we would have had 20 times 8 times 16, which would have given us a volume of 2,560 centimeters squared here. So fairly easy and straightforward. What we want to do is we want to take a look at this and see if we can figure out what method is there that I can use anytime I want to find the volume of a prism. Well, let's break it down a little bit. The first thing that we did here is we took 20 times 8 right here, which happened to be the length times the width. And when we multiplied the length times the width, we were finding the area of this bottom part right here. And we know that the bottom part we call the base. So really here, this is the area of the base. We can use this method then. We took the area of the base and we multiplied it by 16. So we're really saying here that there are 16 layers of the base, or 16 layers of the 20 times 8, which happens to be 160, and we multiply those together, we get our 2,560. So all we really did here was we took the area of the bottom rectangle and we multiplied it by the number of rectangles that would sit on top of each other in this one, which is 16. So if we take this and we break it down a little bit, the area of the base, all we did was multiply that by the height. This is going to turn into our new volume formula. We're going to say that the volume is equal to the area of the base, which we're going to use a big B to represent, so area of the base times the height. And we can use this regardless of what type of prism we have. So let's take a look at an example. Here we have a triangular prism because the bases, the top and bottom, here and here, are triangles. So according to this new method we just discovered, it means we should be able to find the volume by taking the area of the base and multiplying it by the height. What we need to do here, the only thing we really need to do is find the area of the base. We know these bases are triangles, and we know that to find the area of a triangle, we take 1/2 times the base times the height. So here we have 1/2. The base of my triangle and the height of my triangle always make a right angle. So we're looking at this side and this side. The base is 6. The height is 8, so we have 1/2 times 6 times 8. I know that 1/2 of 6 is 3, and 3 times 8 is 24. So that is going to give me that the area of the base is 24. All I need to do now is substitute that information into my equation. Volume equals area of the base is 24, we just found it, times the height. The only decision we need to make is what number is the height. The height is how tall the prism is. The prism always sits on its bases. So if we sit this prism on its triangle, the height is how tall it is, or the distance between the two triangles. In this case is 12. So to find the volume, I'm going to take 24, which was the area of the triangle at the bottom. I'm going to multiply it by 12, and I'm going to get an answer of 288. There's nothing specified here, so I'm just going to use units to the 3rd power, units cubed. And that's how I find volume. So no matter what type of prism we have, we can find the area or find the volume by taking the area of the base and multiplying it by the height. So the only things you're going to need to remember are the area formulas for things like triangles, 1/2 base times height, rectangles, base times height, parallelograms maybe, base times height, and trapezoids, which are 1/2 times the height times the sum of the two bases. Anything over a trapezoid, we have learned methods for. We could split them into triangles. We looked at pentagons when we talked about surface areas. If I made this a regular pentagon and I put a dot in the center, I know that I can split this into congruent triangles. And if I'm given what we called the apothem, that point from the center here, I could find the area. So that's one way to do it. Otherwise, I would simply tell you that the area of the base, labeled big B, is something like 15. So we have multiple different methods for figuring this out. So use this information to answer the questions on the worksheets that are described for you. Remember, all you need to do is find the area of the base and multiply it by the height.